Okay, let me get things rolling here. Make sure my audio, make sure everything's coming through good. Yeah, we'll bring that in just a little. Okay. Hope everybody's had a good week. It's been actually more than a good week. I hope everybody's had a good month. As you can see, we've got kind of a studio space. My lighting got lots of wonderful shadows, so we'll figure it out. It's okay. Progress. I do actually look forward to this space here. I think it's going to serve us pretty well long term. I didn't get to do a whole lot of testing. It's been a crazy week, and I'll get into some of that. I've got some really interesting stuff that kind of went down this week, and I can talk about that system design that took a lot of time to kind of set up and prep and do just what it takes to do that kind of stuff. How you doing, Jason? What's up, man? It's crazy times, guys. It's interesting just how much just how much is happening even in the industry, just how many things have changed. That's something that kind of hit me this week is, I've been in this for right at 10 years now. And thinking back, and how things were 10 years ago when I first got into it, and just how I've seen things change since then. It's interesting. It's really interesting, especially with the manufacturers. That's something I think I've noticed the most is the relationship with the manufacturers has dramatically changed, and not in a positive way. And something I've really noticed is the manufacturers are doing a lot more to compete with the everyday person. And it kind of makes sense, when I really start to think about it and I get into just why it would be that way. It begins to register to me that, well, ultimately it's because they're trying to compete in the same market we are. For a long time, the manufacturers didn't do much more than just service their specific equipment, do their specific warranty stuff. Just they honed in on those types of things. When you needed factory support because you're on a job doing whatever and you couldn't figure it out, they would come out and they would give you a set of hands to get through whatever it was. That was where we had a really strong bonds with the factory. We could build great relationships. It went really well. And then what I've seen is as the economy and as things have developed, their approach and their mentality and how they're coming at doing things in the industry has also changed. And I really think it's probably got a lot to do with the drive behind their shareholders, and they've beat certain margins, and everything's expected to continue to grow when there's only so much you can grow inside of an industry. And so what we've really seen them start to do as manufacturers is they're really starting to push a lot heavier than I've ever noticed them in trying to do a side by side competition with us. A lot of the time, unless a customer came to them and specifically wanted to use the manufacturer only, because they're a lot more expensive all the time, like all of them are. Unless they wanted to use them specifically, they rarely would do that much to be direct competition in the field. And between just them being the manufacturer, they always had enough work to take care of stuff. And it was, most of the manufacturers didn't have real big shops and operations locally. But again, we've started to see that change. We've started to see them kind of expand and them kind of hire, and now we're seeing less field support. 5 years ago, it wasn't that hard to get true, honest tech support for a variety of brands. And we could just call in. I'll use Train as a prime example. We had a direct tech support line, whether you were working on IntelliPacks or chillers. It didn't matter what you were working on. when you had an issue, you could call into that tech support line, and they would help guide you through whatever it was you're looking at. We You don't have that anymore. All that was shut down, and the only type of tech support they actually provide without going directly through their local service shop is like on their 25-ton and below rooftop systems. You can send an email to this online website and form and hope that they respond back to you within a certain time frame, and then maybe they'll provide you some form of like email written tech support as to what your problem is and what they recommend. It's a joke. It's anyway. uh, Things have changed. It really hit me this week. Part of that post I made with the picture on my community tab within my channel was a system design and something that we're having to do. We've got well, they're 95-ton split system changeouts on a high rise downtown Austin, and we couldn't get submittals, like piping submittals from the manufacturer. We asked and asked and asked. Honestly, we spent an entire year trying to work through it with them. Now, this is our sales side. They eventually had to get me involved strictly because the manufacturer wouldn't support us in ways that they typically would or should have tried to take care of us. So now we've had to take it upon ourselves to create our own personal design, reading their specifications and trying to, make the best of it, as that we can. And yeah, it's that whole situation really just hit home and made me realize that I'm just complaining at this point, but the trade of today is not the trade it was yesterday, and that's okay. That's growth. That's life. It is what it is. We've got to accept that at some point and move on. So here I am, accepting it and moving on. Have you registered with Train for any help with Train now? So right now, what we have to do at this point, if we have a problem with any kind of Train product, we have to put in a service call and hire Train directly through their service mechanical side. Uh, if that's the only way we're able to get any kind of support. Now we do have relationships within Train, our local shops, so sometimes we can kind of leverage those and get a little bit of support, but it's usually not very much. Most of the time it does turn into, if we need them, we have to bring them in and pay them to do that separately. So yeah, it's not just, yeah. Anyway, I called Train tech support once and they said they won't help technicians. So they said to call back and act like the homeowner. Yeah, yeah, that's funny. It's sad, isn't it? It's sad. I will tell you, I appreciate Daikin and LG and Mitsubishi because they are some of the few manufacturers actually offering legitimate tech support. Specifically, I'll say LG, and this is something else that's changed. I'll kind of hit on it real quick. LG really changed, or what am I saying? LG, you really don't know what you're going to get. And this is where the couple of tech support options we do have now, I do have some complaints about. I should be happy just to have it to begin with, which I am. But they're very inconsistent. And there's been several times where you could call in, and depending on who you talk to will depend on the answer you get. Like one prime example is LG recommends if you replace the blower motor inside of a fan coil, you need to replace the blower motor and the PCB control module, and there's one other module in there that's part of the power assembly for those fan coils. You've got to do all of those components, and they tell you that, or they don't always tell you that. So we've had a couple of times, and I've had technicians that went out there, called tech support, diagnosed bad motor. The guy they were talking to didn't communicate that. They hadn't ran into that before. Because I remember the first time I ran into it, I didn't know. 'Cause that's exactly what happened to me. I was doing this exact problem, troubleshooting through a control board. I diagnosed the PCB actually to be failed, and I verified that through tech support on the phone. Well, so we ordered that board, put it in, the brand new board got put in, and then instantly fries. And like, well, what the heck? And that's what it led to. Several. The fourth, yeah, the fourth tech support person I talked to was finally somebody fairly competent and was able to tell me that I needed to. It was the blower motor, because two of them had already said the blower motor didn't have anything wrong with it, but the final one said, yeah, no, this reading and that reading is not okay. I had the same readings every time I talked to somebody. Readings didn't change. So he told me the readings weren't okay, got a new motor, got the two new boards. Finally, after all of that, and at this point, I'm on my dime because it's already been misdiagnosed and repaired multiple times. So I'm not charging the customer for this anymore. You know, that hurts. The point I'm making is for a long time, and when I was first coming up in the trade, when you called tech support, you almost always got somebody who was a real technician. It was actually somebody that had spent, 20, 30, 40 years in this trade. And, they've done they've been through your exact situation 100,000 times, and they were able to support you and really take care of you. And I think that's part of what led to the manufacturers getting away from the tech support system. Was one, they wanted to compete more in the market itself and trying to improve their revenue. But two, the people that they had that were so good at that and helped so many of us for years weren't there anymore. They all retired or otherwise, and so when those guys started to go, they didn't really have anybody to directly replace them most of the time. I know Sears, granted, not really our side of the trade, but Sears was a prime example of they were doing crazy deals, just trying to get anybody to come into their tech support center. I mean, just about anybody. They were very loose with trying to hire just so that they could have people to sit on a phone and punch things into a computer to talk to somebody on the phone out in the field. Like it was crazy what they were doing. But that's just evidence kind of what has happened. And then I think part of what led to that, and not trying to knock on anyone, but the boomer gap that happened where we have this whole wave of the baby boomers that are starting to retire out of the trade. There wasn't very many of us in the middle, and now we've got a whole group of us down there at the bottom trying to figure it out. We don't have that extra guidance, and so that age gap that was there ends up creating a vacuum where there is nobody to really fulfill those tech support type roles. So there's a lot of variables I think that have played into that inevitably happening. And I see the chat is going pretty good. Let me try to catch up on a couple of these. See, lucky I have a trained field tech. Yeah. Now this is where relationships become really big. You really need to uh, to have strong relationships in this trade. I think you. Now we do have a TU license. Everything HVACR. We do have the TU software and license, but train in our area, and it may be different because one of the things I've learned about the manufacturers is it does depend on your specific region, just kind of what level of support you can and cannot get. Train in our area, I tend to have to beg a lot more than I think others. But what do you think about Carrier? I'll keep my opinion of Carrier to myself. I just Carrier's a lifelong brand in this industry. They do have a strong reputation, but what they've done with the Carrier brand and the people that are running Carrier, yeah. I'll put it this way. The most problems I almost always have, whether dealing with a manufacturer or the equipment itself, are almost always Carrier related. I just yeah, yeah. Sorry. Hope I don't bust any bubbles there. Not trying to offend anybody. I just I've got other preferences. ABB does actually have some pretty good tech support. I'm glad you pointed that out. I don't always think about them because it's not very often I need to call them, but ABB does have some great tech support. Uh, the 480 was too high for a unit with a data plate of 460, and it was causing a problem. Oh man, that's a good. Okay, so Dan Brown's got a really good one in there. So yeah, he said that he had an LG tech support insist that 480 was too high for a unit with a data plate of 460, and it was causing the problem. And he says he ignored that and changed the power filter board, and problem was solved. That is hilarious. Yeah, that's a prime example of what I'm talking about. Yeah, 100%. Can you explain the sequence of the Y delta starter step by step? Yeah. Well, I say yeah. Basically, so when you have a Y delta start sequence, you've got three contacts. So you have your run contact, you have a uh, secondary, or you have your primary, your run, and then you have your start or your shunt contacts. So the first one in this series uh, is going to be the main legs that cross over. So that's your primary side of the delta windings, right? So when you have a delta sequence, you're talking this large of a motor. You've typically got six legs coming out of the motor going into your contacts. Instead of what you might think of as three, we would be using six in this instance. So basically what we're doing is the motor itself is going to run in a delta sequence pattern on the windings. But if we try to start the motor straight from a delta sequence, locked rotor state, it's going to draw a ridiculous amount of inrush current. And we're talking, on a 50, 100 horse motor, you're talking thousands of amps trying to do on an inrush. So what we can do is we can get a pre-rotation, meaning we can get a little bit of spin, get out of a lock rotor state, and we have a higher torque at that point with a Y circuit than we do using the delta. So my understanding is the delta configuration is more efficient than a Y, but Y has more starting torque, and it's got a lower draw at that starting point than a delta would, is the way I understand it, at least. Anyway, so your sequence would be your mains would hit, so your primary contact would hit, and you're going to see your start contacts hit. Your center one is going to stay out, and typically your run contact and your start contact will have some sort of interlock, like a mechanical swing arm between them, to where both can't engage at the same time. They cannot engage at the same time. They will go boom. Anyway, and so the start contact, what it's doing, if you look at the legs on it, it's got the three power legs coming in the bottom, and then there's a jumper bar on the T terminals of that starter. And what it's doing is it's literally shunting those legs across, and it's manipulating the windings wiring so that it creates a Y wired circuit. So typically, if we're gonna wire in a motor in a Y fashion, we would wire a couple of legs together. Instead of having six legs come out, you'd only have three. Well, basically, that's what we're doing with that start contact, is we're shunting across those three legs to make them as one to create a Y circuit. So that starter will kick in, and it usually will hit for a matter of just seconds. We're talking 3 seconds, 5 seconds tops. And during that whole time, that the primary contact will stay in, and then you'll hear a transition where your start contacts will release after so many seconds, and your secondary run contacts will hit, and it will create the delta circuit, which the motor can then run. So that'll take, say, a starting current of an inrush of like 2,000 amps, and it'll take that down to where that inrush may be 500-600 amps instead, significantly lower. And it makes it it's just a much better starting sequence than a XL start. So your XL start is just a straight across the line contactor. It hits, it goes. That's all it's doing. That's where you're going to get that really high inrush current, during that time. And most of the time, you have to wire that motor to like a Y circuit, which is, again, my understanding is it is less efficient of how it utilizes the windings versus a delta circuit. And I do want to point out, because I have had to learn this the hard way, is there's a difference between Y delta transformers and power for a building and a Y delta Y or delta winding sequence for a motor. They are two different things actually. So I had to learn that the hard way. I got in this really big debate with some of our suppliers and trying to figure out the right application for this motor, and we were having some weird issues with it. And I had to be educated by them, and eventually understood that, okay, I had it in my head that Y delta power for a building was the same as the Y delta sequence on a motor, and that's not true. Because with a Y delta transformer on a building, when you have it in a Y sequence, which the vast majority of, actually almost all of the commercial space in my area has Y transformer sequences on the building providing the 480 or 208 power, meaning that all three legs are even controlled, and you've got a you have the, it's actually, it looks like a Y. Literally, it looks like a Y. You've got, everything comes to a central point for your neutral, and the other three legs kind of come out away from that, right? That's your Y circuit. And in most of your building transformers, if you ever weren't sure, you could literally walk up into one of the electrical rooms and read the data tag on that transformer and sitting on the floor and see what it says that it is. Anyway, a delta transformer is going to have what they call a wild leg. So that's the one that makes a triangle pattern, and the legs kind of come, or you've got your 3 points where the legs come off, then you have a neutral point kind of halfway between one of the, or two of the legs, right? That's your delta sequence, and that one is going to have, like I said, a wild leg. So two of the legs to ground will look as they should, and one leg, say if it's 208 volt, one leg may be 190 volts, and it'd be perfectly normal. But you read leg to leg, and you're going to see the proper voltages leg to leg, and you're not going to, anyway. That is where I was messed up in my thinking for a long time, and I eventually now understand that a Y delta motor sequence, that motor is still running on a Y configuration on the building power, but the motor is wired in to where the winding is running in a delta state for an electric motor. Anyway, I hope I didn't go too crazy off on a tangent there, but Sanchez, I hope that answered your question in a long format. All right, let's see. I'm 3 months in. Love the work. Came to being a cable technician. Oh, that's interesting. Yeah, had a decent tech support. This ain't good to hear. Is it just Train? No, it's not just Train. I use Train as a prime example, largely because majority of the equipment in my area is Train equipment. So I have the biggest impact by Train. So I tend to use them as an example because they're just so fresh on the brain. But they're all doing it. It's not just Train. Sending some services to India. Siemens let most of their controls in. Interesting. Okay. All right. I will kind of roll through some of our videos for this month. Kind of do some recaps. The electrical training video. Honestly, that thing took off. I've had a couple of videos get into the tens of thousands of views, but that the advanced electrical training that I went through, and all that was filmed live with our team. Well, not live, but it was filmed for our team. You know, I do in-house trainings for them, and those videos are those trainings. We just film them so they can review it later. Anyway, yeah, that's a pretty successful video. I appreciate everybody's support on that. Had a lot of fun. We've built those electrical trainers. This past month for February's classes, there won't be any videos for it. They were strictly lab classes. So we took those trainers and we built that carrier panel that you saw, and I also built a train chiller panel and fully built it out as well. And so what we did for February is we all came together. I simulated a bunch of electrical problems in both panels, and then everybody had to go out and see what was shorted, why we were tripping different alarms, and you know they worked together as a team. What we're going to do for our March, so March won't have at least a minimum for our mechanical training. We're going to do an advanced brazing. Now I've kind of gone back and forth on it, and I'd be interested in some feedback, but I've considered kind of doing like a vlog style instruction where as I'm kind of helping guide and show guys, I might film different portions of the class, but it wouldn't be like a standard, just a static camera watching the whole thing. It'd be just a wasteless point, wasted time trying to do something like that. Nobody's going to benefit from it. So I am curious, is that something, you know, you would like to see? Because part of what it is our guys have a hard time, especially when we start dealing with dielectric metals. So we're talking, you know, a steel port on a compressor going into a copper port, like an 1 1/8 size or something like that for a discharge line, or 1 5/8 for a suction line. Or there's some scenarios where we have to sweat in isolation valves that are, say, 1 1/8 or 2 1/8, not 1 1/8, like 1 1/8 or 2 1/8 size ball valves, and the guys have a really hard time, you know, really getting that 2 1/8 hot enough while not overheating the valve itself and damaging it. So that's part of what March's exercises will be, is them kind of getting honed in on the technique. And basically, what I've got in mind of doing is I'll take a 2 1/8 line and put a coupling between them, right? And then on one of the pipes, I'll wrap it with a whole wad of wet rags and simulating, you know, within a couple of inches of the joint, simulating what would be a like a ball valve there. So instead of having it a literal valve, we can simulate that heat rejection through it and how that's going to affect their actual local brazing point that they're working on. So anyway, that's going to be March's class on the mechanical side. I think for April we plan on doing another like an advanced refrigeration refresher as well. So anyway, those are some future trainings we got coming up. I may have some of those filmed. I may not on some of them. It just kind of depends. So stay tuned for that. If you haven't seen the electrical one, I do recommend it. And I opened the whole thing up with the premise of we have to understand as an industry that our series-based troubleshooting is rapidly going away. And we're going to have to understand and transition to a mindset of IO troubleshoots. And this is just the reality of our trade and what we're going to have to do going forward. So you really want to get on board now versus later. It can only be a 12-pole motor. Is that correct? 12-pole, no. No, Jason, I think we have six poles on ours. Most of our Y deltas we run are 6, if I'm not mistaken. I could be wrong on that. I don't look at me as too much of an expert there. The IGBT, actually, this bad boy right here. Yeah, this change out went really well. It's a couple of points I do want to point out is this compressor did actually have a bearing issue. So one of the things that I've learned, this is a IGBT from a York air-cooled Raptor drive or their VSD. So your 3 legs here, so this would be actually this is your input side. This would be one input, another input, and then your third coming off of the DC bus and the capacitors, and that's going through a series of SCR, silicone controlled rectifier gates, and passing out and creating phasing over here. So we're inputting DC voltage, outputting an AC current or sine wave. It's a PWM, pulse width modulated wave, yada yada. VFD theory 101. Anyway, what we found with these a lot of time is that when the motors start to get a really heavy harmonic in them, and it will sound like bearings. The first couple of times I ran into it a number of years ago, I genuinely thought it was a bearing issue. And after doing some research and then actually getting a second opinion from the manufacturer, we had them guys come out and look at it as well. Uh, it turns out that uh, those can create a harmonic noise in the compressor that sounds just like a bearing issue. And it's just when those gates begin to get weak and they can't quite output a real clean frequency like they need to, it creates a harmonic vibration in the rotor. It's some really wild stuff. And now, if it's allowed to run like that for an extended period of time, it will damage the bearings, and that is what happened to this compressor. So it's a York YCIV chiller, air cooled screw compressor, and uh, anytime we do a compressor, we always do an IGBT module with it. Period. It's just something we've learned. I don't know that York specifically recommends that, but it is my personal recommendation, and most of the time the customer does agree with that and go for it. It is worth the investment, believe me. Anyway, what we were hearing that harmonic noise. We knew that okay, we're probably gonna have to replace this compressor. It is what it is. We're gonna have to do the IGBT anyway. So before we take it as far, because we could not 100% identify without switching IGBTs around and doing other funky stuff, which I mean sometimes I do. But anyway, instead of doing that, why don't we just go ahead? Let's get a fresh IGBT on it. It's not going to hurt the IGBT to put just a few hours on that compressor, even if the bearings are bad. But we needed to eliminate the IGBT because I've had several compressors that we were on the edge of condemning them for a bearing issue. We turn around and do the IGBT on it, and the compressor sounds brand new. And it had nothing to do with the bearings the entire time. So we did that here. We put a new IGBT in, and it completely took the harmonic noise out and left the bearing sound by itself, which most of the time, that's not the case, but it was on this one. So we are going to have to replace that compressor. It is what it is. We did an oil analysis at that point, and we did find that the ppm on the iron count was like 55 ppm, which is above what it should be. So which only goes to confirm the bearing issue to begin with. We didn't really need to do the oil analysis. We were actually there doing annual PMs on the chillers anyway, which is included as part of our service. So that's when we found that, recommended it, quoted it to the customer. We'll let it go from there. The A-on no heat. I don't have a ton to update on that other than it never tripped again. That is one I will say. I don't have a lot of them very often that really trip me. When I do have them, I try really hard to get those on camera. I'm glad I decided to go ahead and film this one because I walked into this one thinking it was just going to be a couple of quick parameters in out, but that little bitty tiny like 5-ton Aeon whooped me. So it was quite literally somehow on the mod gas module, it got locked out and I couldn't even replicate it. I tried to kind of replicate and get it to redo what it did, and I couldn't. And I did have some comments I will follow up on about, well, maybe somebody went in and locked it out, or maybe they found the heat exchanger was bad, something along those lines. It's possible. I extremely doubt it because that customer is very engaged on that building and that account, and I really think he would have known about that, and he wouldn't have let that happen. So if even if another company did come and shut that heat down intentionally on that unit, one, they didn't kill the gas valve, which is in our area the standard. Everybody knows as a technician, if you're going to condemn a heat exchanger, turn off the gas to the unit entirely. That is what almost everybody in our region does. That wasn't the case. And I really doubt somebody took the time to disassemble this unit to even get to the heat exchanger. It's on the blower is on a track, but it's not easy to get to. So anyway, I don't think that's what happened. I think something crazy happened in the controls, or somebody was fidgeting with something and it locked out, and it didn't make any sense to me how it happened. How I got it to release, which I'm pretty sure I had talked about it in the video, but I just ended up holding down enter, which I've had just some random luck with this before. It's the only reason I even tried it. I just held down enter on the status menu, and it triggered out of whatever it had locked into, and it cycled, did everything it was supposed to do, has been perfect since then. And even to this day, I've not gotten a call back from it, and that was a solid month plus ago. So we've had several below freezing days since then. Actually, that happened right as our initial first major freeze was coming into Texas, or into Central Texas specifically. Anyway, it's doing fine. Haven't had any further issues. Genuinely think just a weird glitch, and yeah, it got us. It was challenging. It tripped me up pretty good. Da, 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 da. Let's see here. 56%. Yeah. Yeah, I'm at brazing. Is that electrical training video on your channel? Yes, Tech TI. It is. It was a few weeks ago. If you go to my channel and just look at my list of recent videos, you'll see it. It's not too far. The thumbnail is literally me standing in front of a whiteboard, and I had a carrier chiller panel here next to me, and it's do you know advanced electrical troubleshooter diagnostics or something like that. Anyway, that is on my channel. Hopefully, it shouldn't be too hard to find. Let's see. Do I have any other planned YVAA tips or tricks? Let me think. I don't know that I have any planned ones. I am getting ready to do a YVAA install. So we've got a set of old YCIVs on a building. We're getting ready to pull, and we will be going back in with YVAAs to replace them. So that'll be a fun one, but that's going to be a minute. We're in the early stages of ordering equipment, which actually, I'm curious to get some feedback as to what y'all are seeing out there. But we're literally like 11 to 12 months out on any kind of equipment orders right now, including chillers. So if the customer wants to change this chiller out, they've got to order it now to hope that they have it by this time next year. So, and this is their estimated date. I got crap all over my hands from that heat paste. Anyway, this is their estimated dates, which means that you could basically add anywhere from 2 to 4 months in addition to that in delays is the pattern we've seen. Usually, if we're told 8 months, it's usually like 10 to 12 months actually getting all the equipment, everything we're looking for in. So yeah, that's coming, but not immediately around the corner. The lawn card, that was just, I don't know, that was just a fun video. Lawn card got installed, Train Tech came out, plugged in the rover tool, uploaded the program. Then the buildings automation company was able to come out and readdress all the points to that lawn card and communicate with the chiller and yada yada yada. So it wasn't anything too spectacular, just a fun video more than anything. I will say though, so I talked fairly heavily in that video about how that controls sequence is set up, And it is a problem. And I think I even made some text notes at the bottom that we are modifying it. So I'll talk a little bit about that now. But we'll probably start on that this next week. The the original sequence, and they did this on both buildings, but the original sequence is the automation fires a relay that turns the building or the circulation pump on for the chill water loop, and that pump closes a flow switch, which then that flow switch closes and enables the start stop at the chiller. Now in the chiller they had the flow switch jumpered on the original RTAAs, which you could do that on those. They had the flow switch jumpered out, and the flow switch at the pump actually served as a flow switch and start stop for that chiller, and that works fine. And those older rudimentary systems did that. We've got several buildings where the pumps turning on and closing a flow switch actually enable the chiller. It's not the only building we've had done that way. It is how a lot of people did it for a long time. This building originally had pneumatics in it that are still there, first of all. Second of all, they're kind of like in a halfway done hybrid system on their automation system. So it's a mess. But that new CGAM is not going to accept that type of control sequence because it's a lot more critical in how it's monitoring flow and verifying that flow is actually happening properly. So what I'm going to have to do is I'm going to reroute the start stop from the pump because I've only got that one input coming from the automation. It's just purely one set of wires for a start stop from the automation panel, and it's not feasible. It's doable, but not reasonable for me to try to run wires all the way back to the automation panel underground, going about 400 feet back to the building. We've got a really long way to go for that. So I'm going to reroute that start stop back to the chiller and just land it at the chiller start stop on that top left hand card in there. That's your start stop and emergency stop card. That way, when the automation closes the relay, it's going to engage that start stop on the card. And then I will have a separate set of wires there at the plant where I'll run a start stop through the chiller controls. So terminals 30, I think it's 30 and 31 or 33 and 34 on that lower terminal board on the bottom right actually is your pump one start stop for that chiller, to where that chiller can take full control of that pump. So that's what we're going to do. We'll run a set of wires back through the pump starter for that, and that way it will take care of that on its own. Now the flow switch that is currently there that we technically just put in with the chiller is no longer going to be needed at that point because the chiller has its own flow switch internally on that CGAM. But the customer wanted everything to be uniform, so we still have some older RTAAs there that are configured for the old way. So we also have to go in and we're going to upgrade their wiring as well, so that the automation is actually controlling the chiller, and then the chiller is going to control the pump directly. Ultimately, it's going to take basically about a day to rerun some wire and to do some stuff, and then just verify it all works. So it's not going to be that big a deal. But that is what we are going to do. That was the final plan that we settled on. Don't know if I'm gonna do a video on that project or not, but we'll see. Like I said, we'll probably start that this next week. Let's scroll through a couple of comments real quick. Let's see. Everybody's jamming. Hey, Holden, can you please explain what harmonics are or what makes them appear? Certain frequencies on the inverter-driven equipment can cause vibrations, and then sounds from those vibrators. Certain frequencies will be more audible than others. That is absolutely true. And do all kinds of weird stuff. Yeah, so Sterling, part of what Frylock was saying does technically apply both ways. How you doing, Frylock, by the way? If you don't know, I'm going to kind of oust him here a little bit. Frylock actually works with me. He is at our one of our other branches, but me and Frylock connected. I don't know. It's been a couple of years ago now. Actually, it's been a while, and we've kind of worked together back and forth. We ended up having a solid opportunity open on our team. He came in, filled that role. Has been a great member of our team ever since. So really appreciate that guy. But anyway, the harmonics can do a lot of different things, and ultimately, the biggest thing that it's doing is it is actually creating a magnetic field frequency that is outside of what it should be, right? So, in terms of if it's happening inside of a stator, you got to remember your rotor is picking up the magnetic field from the stator, and that field needs to be even and balanced. And so what can happen is when the frequencies coming into that stator aren't very clean and aren't very crisp, it will cause a disturbance in that magnetic field, which the rotor will pick up on, and it'll cause a shudder in that rotor as well, which eventually generates into wearing out your bearings because, well, the rotor is literally fluttering inside of the stator. In the same way, when we have electronic components as well, and why you can't run communication wires next to main power sources or anything of that nature is because it's those magnetic fields that are being generated. And one of the drawbacks to drive equipment is it creates a it's an unnatural field. It's not very clean. It's not very pure already. It's good enough to function and run, but when other things start to get too close to it, that field will quickly begin to affect them in ways that if it wasn't a drive, right? So if we're talking about main power coming in straight from the grid, that natural sine wave that gets generated at the power plants and sent out is a much cleaner version, and it's a true sine wave. It's not a pulse width sine. And so, a true sine is the classic, dips and peaks that we always see. Where a pulse width is quite literally it's a pulse straight up, half second positive pulse, back down to a neutral, over, back down to a negative pulse, over, back up to a neutral, over, dot 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 dot, and it creates this little box looking thing. It's not a naturally clean sine, and the field that gets generated around that and from that is it has a lot of interference. Its ability to affect other magnetic fields processing around it, or say the pulses going through a communication line between components, becomes very high. It has a lot of electrical interference that it's affecting, and it's doing that in a lot of different ways. I'm trying not to lose my thought. I hope, Sterling, that kind of help made sense. Um, yeah, you have to be really careful. Just in general, you have to be really careful not to put any kind of sensitive electronic equipment directly next to drives or the power lines going through them. They will cause interference, and so most of the time, like if we're in a mechanical room, granted it looks tidier to begin with, but you'll always see us put like building management control systems or the automation controllers inside of a enclosed panel. We may have drives right next to that panel lined up, but they're usually always inside of an enclosed panel. Genuinely, it's mostly cosmetics. It just looks cleaner, nicer, yada yada, and you can close that panel up. But it also does play a benefit, and it is an insulating panel preventing any kind of interference from that drive being able to leak over and cause disruption on the comm lines or anything else to do with the automation system. So it does have a true dual benefit. Anyway, yes, sir, not a problem. Let's see. Have you had to deal with any York machines with Chiller Access Manager? Chiller Access Manager. I don't believe so. It doesn't ring a bell. So the fact that I'm not 100% sure as to what you're referring to tells me no, I haven't. At least if I have, I call it something different. I'm not sure what it is. What about a NIC 4 to 20 milliamp transducers? Do you think they can be affected if the cable is not protected or shielded from power cables? I've had a couple of PCB with burnt entries without apparent reason. It's possible. It's possible. It depends on, like, are they literally being ran inside of the same conduit? So you're like specifically your VFD output terminal, that wiring harness going to the motor, is that the same conduit as the signal wire going from the transducer and back? Ultimately, I don't know about that one. I wouldn't expect it to have as much of an effect. Something else we are seeing though is the boards and control circuitry and things that we have today. It kind of goes back to my opening discussion on the live stream. Is it's not the same as it used to be. We between moving to triac based control circuits and using these, we've gone beyond micro components, right? So a lot of these would have been considered micro components not that long ago. Like this would be what I mean, as if you could see it, but this is a little capacitor that's considered a micro component. But then this tiny little thing that's about the size of a tip of a pin is also a capacitor, probably a similar rating in capacitance, and it's a nano component. One of the problems that we have is going to these really small type systems. They're cheaper. They're cheaper to do and manufacture, but they don't have the same. They're just not as durable as a full size electronic component would be. For example, we'll come back over here to these IGBT, which they don't even have. So these capacitors, these are electrolytic capacitors. These would be considered a full size electric component. And these IC circuits, integrated controllers, these would be considered a full size, and so would these little transformers as well. All these others are considered a micro component, and they've only got a couple of nanos actually built into this one. Most of them are micros. You don't even have just a regular resistor anymore. Used to, we could open up a control panel and that would be what we'd find, and there were methods of troubleshooting and doing stuff with those, and even replacement of them wasn't that big a deal. My point is, that's how all of these components are being built, and the drawback is they're not going to be as hardy as systems used to be, and they don't fuse protect them as much either. With our PCBs and things going further and further into input output based components, all the fuse protection, there's so much more happening inside of that board, and that's one reason why they've gone to nano components, is so they can do more functions in a smaller space, and that allows them to do that. But the drawback is it's not going to hold up the same, especially in areas like mine. Here in Central Texas, we have horrendous grids. I mean, it's between the brownouts and surges and just it's very dirty power. Those PCBs are too sensitive for that, and it's gonna cause them to fail. That's why we also have VFDs fail all the time as well. So, um, yeah, it's tough. Let's see. I got some updates. These units, they run the transducers alongside any other cables. Okay, this OEM doesn't bother shielding sensors, cables, or transducers. They just run them all over the place, mix them inside the electrical panel. Yeah, I mean, that's honestly, we see that on a lot of equipment. I know Train and York, or even Carrier, all three of them are real bad about that kind of stuff. Um, no isolation relays most of the time. Yeah. I've had a burnt EEV drives with no apparent reason too. Yeah. Well, and that goes back to just general manufacturing quality right now. I'll tell you a story, and I don't really even necessarily blame Train because Train is buying it through Danfoss actually. So if you wanted to blame anybody, you could blame Danfoss. I've I've had two instances actually. The first one that involves Danfoss is their EEVs. We had a situation where I've actually had several jobs over the last 2 years where we would put EEVs in, and within 2-3 months, brand new EEV fail. I've had the same thing actually happen with York as well, and they're using. I don't think theirs are Danfoss. I think theirs are Sportlands. And so, and it just comes down to nothing changed. Like what's failing on them isn't even mechanical. It's electrical. The little motor drives, yeah, they go out all the time, and it's the only difference that we have compared to the original component and now is the process of manufacturing since then. I've had I've talked about it before, but I had a scenario where Train, I literally went through. It wasn't until I got the fourth motor that it was actually good. The first three, one came with open windings out of the box. Another came with a locked rotor. The bearings were just completely seized out of the box. And a third one came, it had a winding issue as well, out of the box. And these were brand new, sealed by the factory. These weren't even boxes that looked like they'd been tampered with. They weren't beat up. They weren't any of that. It just came that way. Finally, on the fourth motor, after all these got warranted directly by Train, we got a good motor. And the only thing I can blame it on is the manufacturing processes and the strains and struggles that's there right now, and the lack of technical skill at these manufacturing facilities. We're having chillers show up brand new. The brazing joints on these, not even chillers, RTUs included. The brazing joints look like a 5-year-old did it. And I'm not trying to harp on the people. I'm not even going to tell you what manufacturers they were. But that's what's coming to us. Like their quality control, even for brand new equipment coming from the manufacturer directly, is it's just not good. It is not good, and I don't know that it's going to get any better for a long time. It is what it is. We've got to deal with it. Sometimes there's not a real reason other than it just didn't last. It just flat didn't last. I've had to come to accept that the hard way. Let's see. Okay. I'll start to kind of conclude. I do want to just let everybody know that I am working on kind of expanding the website of HVACtimetx.com. I do want to I want to do more with it. I initially created it with just the kind of like a merch store just to get it off the ground, and I'm still learning, and I've never built a website before or done any of this stuff, so all this is new for me, and I'm figuring out as I go. um, I am one to just personally believe that if I'm going to do something, I'm going to learn how to do it. I'm not crazy about trying to hire everybody to do everything for me. That's just me, my own personal quirk, whatever. Anyway, uh, that being said, one of the first ways that I am doing that is trying to, I want to get a more solidified list, and I plan on doing a couple of things. Is having streamlined recommended tools for different sections of the trade, right? So if you're a residential guy, hey, this was my residential kit and loadout I used to use when I did residential, and these are the tools I can recommend. In terms of like just a standard heavy commercial technician's layout and bag. These are the things I recommend for this loadout. If you're going to do chiller work, these are things I recommend for this loadout. If you're going to be doing pumps and mechanical work or flack fans, anything of that nature, these are things that I recommend for this loadout. And just you get the idea. Go down the list and kind of have different lists, different things broke out because that is a huge question I get frequently. Is a lot of guys they're not even sure and just what tools would actually benefit them the most, and I've found and I have had the same issue coming up was uh, you don't even know some tools exist sometimes. And I want to create a place and a list and things where you can go and you can look at it, and it might give you some ideas on how you can prioritize the tools you need to kind of help fulfill the goals you have in the trade. Some of those, not all of them, but some of those will be Amazon links, and I will tell you now that I have created a partnership, whatever they call it, and I think they call it affiliate, whatever, with Amazon. So anything that takes you to an Amazon link or anything of that nature that you click on from any of my videos, I'm starting to put that stuff in the descriptions or from the website, wherever you click on it. Uh, I do get a commission off of those things, so I'll tell you that now. I'm not going to shy or hide from that. If there will be a lot of stuff that's not directly from Amazon because, well, if I'm recommending it, I truly am going to try to recommend stuff that I genuinely either have used or I do know works because I've worked with it before. I'm not in this to try to just throw a bunch of stuff out there with the hopes you'll spend money on junk you'll never need, right? Not about that. Um, anyway, I do really appreciate all the feedback I got on the shorts video I did the other day. That was some really incredible feedback. I appreciate everybody's response to that. I got some solid recommendations. I also got some really solid questions on things that some of you guys are interested in. So I'm going to try to uh, put a lot of effort into putting those things together, putting those lists together. I do recommend, Amazon is a real option. I've actually got kind of it's a quirky, funny video. I've tried to make it as a joke while also giving a real point about my opinion and using Amazon as a place to purchase tools. I do believe that it is a real option, and it definitely helped me as a technician building the tools that I needed and getting things, even if they were just temporary items to get me past a certain point. Anyway, I do also really support True Tech Tools. I think they have a great setup. Then they've got a pretty decent selection in a lot of ways. I do also think Home Depot is a really solid option for just some real basic stuff as well. So yeah, other than that, you're using your local supply house. I support that. If you have the option, I always recommend try to use your local supply house as much as you possibly can. End of the day, though, they are limited, and most everybody, bit by bit, is trying to have less inventory for that kind of stuff, and that's something else. Just another way the trade has changed is they have less inventory on the shelf, which means that even if you wanted to purchase a tool through them, they got to order it for you regardless, or they only have just a couple of them, and so you just anyway. Yeah, that is our reality. So be looking for that. I'll keep y'all updated as I get those things put together, as I get them rolled out. I also have been thinking about ways of doing some form of podcast. I don't know. It's something I've tossed around, and I had an idea because I really don't have legitimate time to do a true sit down podcast on a regular basis or anything. I've just got a lot of stuff going on, not only with work but with also with family, and being able to MTT and make the time for them. I just that means I have to sacrifice other time. So with that, I had the idea of maybe taking these live streams and turning them into audible podcasts that you could listen to on the road or anything like that. So if you can't make the live stream, you could always just catch the podcast version later. So I've thought about something like that. Real quick, I would be interested to get some real quick feedback of that, just to kind of see what y'all would think. Jason, I've been talking to the overtime guys, Chris and Bill and them, and it's just a matter of timing, and they've got a lot going on. I've got a lot going on. It's just at some point, yeah, I'd love to go and join their live show and podcast and things. But yeah, we'll when it aligns and things play out, it'll happen at some point. It's funny. They make the joke all the time that they get these different guests on. They're like, oh, we've been trying to do this for a year or 2 years, something like that. It's a joke and it is funny, but it's also kind of reality. It's just the nature of doing what we do. It's not easy getting all of us together at the same time, the same place, and making something like that happen. Now, I also have had an idea of maybe trying to find a way to bring some guests, like actual technicians. Part of the idea behind like some of the podcast stuff was having one of my techs come on and maybe we talk about the week a little bit and kind of share some of the funny stories or just some little odd things. And I've got some guys on my team that are fantastic storytellers. Let me tell you, they have me rolling routinely. There's the two guys in particular. I tell them all the time, guys, if you ever put a GoPro on your forehead and just never turned it off, you would be world famous with the situations you put yourself in. Like, it is ridiculous, the stuff that happens to these guys. Absolutely hilarious. Like, in the moment for them, and not so much after the fact, and they get into telling their story and they're super animated. Gee whiz. I've got lots of thoughts. No guarantees on that. I am very interested to just, would that even be something that I'd be interested in? Anyway, with that, I will close it out. I appreciate everybody. Sterling, I see your question there. Holden, is your company open to candidates from overseas asking for a friend? Yes, 100%. We've talked to a lot of candidates from overseas over time. We've actually had people that have come over and that were like, I have one guy from France. It didn't work out, but yeah, 100% open to it. Obviously, it's not easy. There's a lot of logistics. There's a lot of legal aspects we have to look at and consider as a company. So it's not a simple thing to do, but are we open to it? Absolutely. I have a YCIV gate driver fault appears when it reaches 60%. How can I be sure the IGBT is the cause? If you haven't watched the IGBT replacement video, I do actually cover quite a few tips in there on just little things to really pay attention to. That being said, one of the first things you really want to check when you start having an IGBT fault is that little pin connector right here. So this is like a 16 pin connector that it's just the termination points here are very common failure points. And if you take a little thermostat screwdriver with it plugged in and kind of push those points down, a lot of time it will help resolve some of that. Being the fact that it's tripping at 60%, that would lead me to believe that it's likely, if it is because of the wiring harness, then it's because the vibration is getting up enough to where it just loses proper communication at that point, and the gate kind of freaks out. I would be curious to know kind of what your RLA is and stuff. At that point, you may have some gates getting weak. That's the most common fault to have when that IGBT begins to fail is the IGBT fault or driver fault specifically. So something I have had really good results with, but I very much urge caution on, is switching those IGBT modules around. So if you've got 2 or 3 circuits on the same chiller, as long as you know that that compressor is not in a bad state, meaning you meg the compressor out, it megs okay, it sounds okay, things on the compressor itself are doing what they're supposed to, then you could always try switching out the IGBTs and running a different one on that circuit that wasn't having a problem on the other circuit, and does it still trip, or is it able to function and run? And I actually have had them to where I've switched them out, and even with switching it, the one that was tripping the fault, say it was on compressor 2, it doesn't trigger the fault on compressor 1. I'm still going to replace that IGBT. Even if that happens, you still should replace that module. But it might be enough to get you out of a bind to where it will still run. And as long as the compressor isn't having any kind of amperage issues and there's no symptoms in the compressor itself, you should be okay to run it for a short period of time until you can get the replacement module or anything, just to get you out of a bind. And that would be my thoughts and recommendations towards that. Okay, with that, I will close it out and leave it there. Yeah, it's funny. If you didn't notice it, that natural lioness, that is my wife. So she's because of my time, she's not on board with the whole podcast thing. So if I was to do it, I will not take it down an actual podcast road. And it's where the thought process of maybe doing something with these live streams would also be an idea. So I don't know. Like I said, no promises. She does a really good job keeping me in check. Honestly, I really appreciate her. And granted, yeah, she's listening, so I got that too. But I do tend to kind of run away with the train a lot of times. If you've watched me for any length of time, it'd be pretty obvious. I tend to get ahead of myself more than not. So she does a good job as to protecting me from myself most of the time. Appreciate it, guys. Y'all have a good one. Thanks for listening. I'll catch y'all next one.